When it is reacting with the air, which consists of oxygen, it gives a phosphorus pentoxide. We can synthesize black and red phosphorus just by heating the white or yellow phosphorus at very high temperature. When you are comparing the white phosphorus with the red phosphorus, their physical property will be entirely changed. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called P block elements. Under that, we have deeply discussed with the physical and chemical properties of nitric acid, which are the compounds of nitrogen. In addition to that, we also discussed about the brown ring test, uses of nitrogen and OXOACIDS of nitrogen, and also we have learned about the structure of OXOACIDS of nitrogen, that is nitric acid. Today, let us move on to the next topic of this unit by understanding only about the phosphorus. So, we'll understand what is a phosphorus, how many different types of allotropes will be there, that is a white phosphorus or yellow phosphorus, and red and black phosphorus we are going to discuss. In addition to that, we are also going to discuss about the PHOSPHINE, phosphorus halide and phosphorus pentahalide, and also we are going to discuss about the oxoacids of phosphorus. So first we will understand what is a phosphorus and its allotropes. When it has come to the allotropes, phosphorus has a three types of allotropes. They are white phosphorus, red phosphorus and black phosphorus. Remember, the white phosphorus, which also called as yellow phosphorus, and you can see from this figure and you can understand that how does this phosphorus will be looks. Okay, this is a red phosphorus, black phosphorus, and this is a white phosphorus. Sometimes it is also known as what? Yellow phosphorus also. So these are the three allotropes of the phosphorus. And coming into the in detail study of the white or yellow phosphorus, first I'll discuss with the physical property, and we know that it is a transparent waxy solid and it can be easily cut with a knife. So you can see that this is a white or yellow phosphorus, which is usually transparent and it will be a waxy solid and you can easily cut with a knife. And it has characteristics garlic odor and it is poisonous in nature. Usually when you sense this white phosphorus, it is usually gives a garlic smell, okay, and it is poisonous too. And it is insoluble in water but readily soluble in carbon disulfide. So it is readily soluble in carbon disulfide, that is CS2. And its ignition temperature is low. It is all about 300 degrees Celsius and it is readily catches the fire in the air, hence it is kept under the water. Why it will be kept under the water? Because its ignition temperature is also very low. When you kept it outside, when it is kept outside, it can easily catches a fire and it causes a lot of damages. That is why this yellow or the white phosphorus which always kept under the water, and it glows in the dark, and the phenomena is called as chemiluminescence. What we call for that? We call it as chemiluminescence because even though if you kept a dark condition, it will be glows. This phenomena of glowing of substances, which is known as what? Chemiluminescence, which is also known as phosphorescence because the element is phosphorus. Okay, let us study the chemical properties of this white or yellow phosphorus. Okay, it readily catches with the fire in the air and giving dense fumes of phosphorus pentoxide. What does it gives? So when this yellow or the white phosphorus, when it is reacting with the air which consists of oxygen, it gives a phosphorus pentoxide. You can understand here, this is a phosphorus, that is P4, yellow or white phosphorus, which is allowed to react with the oxygen to form a phosphorus pentoxide. Phosphorus pentoxide. Okay, this is the name of the phosphorus pentoxide. Okay, and coming to the next chemical property, it is dissolved in caustic alkalis on boiling inert atmosphere. It gives rise to the phosphine. Here you can see that this is our yellow or white phosphorus allowed to react with strong alkali, that is NaOH, in presence of water. If you heat it at inert gas atmosphere, it gives rise to the sodium hypophosphate. This is a sodium hypophosphate along with the formation of phosphine. So what is this? This is phosphine along with the formation of sodium hypophosphate. So this reactions which is clearly indicates that our phosphorus can also react with strong alkali and give rise to the phosphine and sodium hypophosphate as a product. Coming into the white and yellow phosphorus structure, okay, this is the structure of P4. So this is the structure of phosphorus, that is P4. Okay, so the phosphorus consists of discrete tetrahedral P4 molecules, and the 4 phosphorus atoms are lie at the corners at a regular tetrahedron. Each phosphorus is linked and remaining 3 atoms by a covalent bond, and it forms a phosphorus-phosphorus bond with a bond length around 221 picometer and a bond angle around 60 degree. So the bond length is 221 picometer. So you can clearly understand that in a phosphorus there are 4 phosphorus atoms will be there, and each one of the phosphorus atoms, they are linked by phosphorus-phosphorus covalent bond, phosphorus-phosphorus bond with a bond length around 221 picometer and a bond angle around 60 degree. And this showing that the phosphorus will have a tetrahedral structure. Okay, what is the structure? It is tetrahedral because it consists of 4 phosphorus atoms. Okay, then coming into the red phosphorus. So after understanding what is a white phosphorus physical and chemical property and the structure, we'll also going to understand about red phosphorus properties. Okay, first we'll go with the preparations of this red phosphorus. Okay, red phosphorus is formed by heating the yellow phosphorus between 240 to 250 degrees Celsius in presence of inert gas for the several days in a iron vessel. Then red phosphorus is heated under higher pressure and series of the phases of black phosphorus will be formed. Remember, you can take either the white phosphorus or yellow phosphorus. Okay. Upon heating under inert gas around 540 Kelvin temperature, it gives us what? Red phosphorus. So either you can write this reactions or this reaction to indicate that how this red phosphorus will be formed from the yellow or white phosphorus. Which you are heating this red phosphorus again at very high temperature, it gives rise to the black phosphorus. It gives rise what? Black phosphorus. This is how we can synthesize black and red phosphorus just by heating the white or yellow phosphorus at very high temperature. Next, coming into the physical properties of red phosphorus, it is a dark red powder and it is insoluble in both water as well as in the carbon disulfide, and it does not show the phosphorescence. What does it indicate? Which indicates that this red phosphorus, even though if you are kept at dark condition, it does not glow at all. It does not show its chemiluminescence property. Hence, it is known as does not show the phosphorescence. Okay. In the absence of the air, it sublimates at 290 degrees Celsius and its ignition temperature is also high and it is around 260 degrees Celsius. This indicates that when you are comparing the white phosphorus with the red phosphorus, their physical property will be entirely changed, right? So because it does not dissolve in water, even though in the carbon disulfide also, and its ignition temperature is also very high when it is compared with the yellow phosphorus, and it is usually dark red in color, and also it does not show us phosphorescence. Here also you can see that how this red phosphorus molecules will be looks like this. Again, there are 4 phosphorus atoms will be there, and each phosphorus atoms they are linked together by phosphorus bond. Okay, coming into the black phosphorus, it has 2 forms, that is alpha black phosphorus and beta black phosphorus. So how many forms will be there in the black phosphorus? There are 2 forms will be there. One is alpha black phosphorus, another one is beta black phosphorus. Alpha black phosphorus, it is formed when red phosphorus is heated at a sealed tube at 803 Kelvin, and it can be sublimated in the air, and it has a opaque monoclinic rhombohedral crystal and it does not oxidizes in air, whereas beta black phosphorus is prepared by heating the white phosphorus at 473 Kelvin under high pressure, and it does not burn in air up to 673 Kelvin. I'll show with the reactions. First, I'll take the red phosphorus. Okay, red phosphorus, if you heat it in a closed tube, okay, you will get what? Alpha black phosphorus and coming into the white phosphorus or yellow phosphorus you can take. If you heat it at a temperature around 473 Kelvin, it gives to beta black phosphorus. Okay. So please understand here, there are 2 forms of black phosphorus will be there. One is alpha black phosphorus and the one is beta black phosphorus. This alpha black phosphorus is obtained just by heating the red phosphorus in a sealed tube. Okay, you will get a alpha form. Whereas the beta form can be obtained by white phosphorus, which is heated around 473 Kelvin at a very high pressure, you will get a beta form. Okay, so this is all about the just introduction to the black phosphorus. Coming into their phosphine, which is a compounds of phosphorus. Okay, so first we will see there how to prepare this, then we will discuss the chemical property. Okay, so first is preparation. Phosphine is prepared by the reactions of calcium phosphide with water and also with the dilute HCl. So first I'll go with the calcium phosphide, which is allowed to react with the water. So what is our product has to be formed? Here our product is phosphine and it is nothing but a compounds of phosphorus, right? Yes. And in addition to this, what will happen? One of the OH to form calcium hydroxide. So calcium phosphide reacting with water molecule to form a calcium hydroxide and phosphine will be formed. Similarly, if a calcium phosphide reacting with HCl, that is dilute HCl, it will form a calcium chloride and also it forms a phosphine. So what is this product? This is phosphine. So these two are nothing but a phosphine. This is how we can easily prepare the phosphine just by considering the calcium phosphide. We have one more method in the laboratory. This can be prepared, that is phosphine can be prepared by heating the white phosphorus with concentrated NaOH in a inert atmosphere of carbon dioxide. So here I have considered the white phosphorus, which is allowed to react with very strong base, which is nothing but a concentrated NaOH we have taken, which has been heated at inert gas atmosphere, which consists of carbon dioxide. What does it forms? It forms a phosphine with the formation of sodium hypophosphate. This indicates that in laboratory we can easily prepare this phosphate just by taking the white phosphorus with a very strong alkali, that is NaOH, in a inert atmosphere of carbon dioxide. So we have one more method. It is purified by absorbing it with hydrogen iodide. When phosphonium iodide, this is a phosphonium iodide which is obtained, which is upon treatment with KOH, which gives to the phosphine. So here the purified form of this phosphine can also be prepared just by considering the phosphonium iodide. Okay, so this phosphonium iodide, which is allowed to react with the KOH, that is nothing but a potassium hydroxide, it forms a potassium iodide with the formation of water molecule, and also it forms what? Phosphine. So this is a purified form of phosphine which has been prepared by using phosphonium iodide. So hope you all understood with the three different methodology where we are going to prepare the phosphine. Next we have properties of this phosphine. First I'll go with the physical property. It is a colorless gas with a odor of rotten fish, and it is highly poisonous in nature, and it is slightly soluble in water, and it is heavier than water. So if you smell this phosphine odor, it gives a rotten fish smell. Okay, so hope you know that the hydrogen will give a rotten egg smell, like that this phosphine which also give the rotten fish smell. Okay, and also it is highly poisonous in nature. Coming into their basic characteristics, the phosphine is weakly basic, even it is weaker than ammonia, and it reacts with the acid to form a phosphonium compounds. Here we have a phosphine reacting with hydrochloric acid to form a phosphonium chloride. Similarly, the phosphine reacting with hydrogen bromide to form a phosphonium bromide. This indicates that it is weaker than ammonia and it is behaving like a weak base. Okay, and phosphine get absorbed in copper sulfate or with mercury chloride solution. Corresponding phosphohydrates are formed. So here I have calcium sulfate. It is allowed to react with phosphine. So what does it happen? The phosphine will be get absorbed on the calcium sulfate to form a calcium phosphate along with the formation of H2SO4, which is nothing but an acid. Similarly, the mercury chloride, which is also allowed to react with the phosphine, it gives rise to the corresponding phosphide and along with the formation of acid. So this indicates that even though when this phosphine are reacting with copper sulfate or with the mercury chloride, so it gives rise to the respective phosphides. Okay, it gives rise to the respective phosphide. This is another important one where we can easily understand from this reaction. Next we have phosphorus halides. Okay, phosphorus gives two types of halides. One is trihalides and it is represented as PX3, and pentahalide and it is represented as PZ5. Remember here the PX3, X will be stand for fluorine, chlorine, bromine or iodine. They are nothing but a halogen. Okay. Similarly here also the X will stand as a fluorine, chlorine, bromine or iodine. Okay. So these are nothing but a halogen. Then coming into the phosphorus trichloride in detail. How to prepare this phosphorus trichloride we will discuss first. Okay. So on passing the dry chlorine over the hot white phosphorus, it gives us the phosphorus trichloride. So if you take the white phosphorus and if you pass this chlorine gas, it forms a phosphorus trichloride, which is a phosphorus halide. The name itself shows that it's a phosphorus halide in the sense where phosphorus which is bonded with a halide. Okay, so here phosphorus is bonded with a chlorine. Similarly, the vapors of PCl3 are condensed in a vessel and cooled with a freezing mixture, and it is obtained by the action of thionyl chloride with white phosphorus. So first I'll go with the white phosphorus, which is allowed to react with thionyl chloride. It forms a phosphorus halide, which is nothing but a phosphorus trihalide with the sulfur dioxide, and S2Cl2 gas will be released. This indicates that this PSCl3 which also react with thionyl chloride to give a phosphorus trihalide. And coming into their properties of this phosphorus halides, okay, it is colorless and oily liquid, and it is hydrolyzed in presence of moisture. I'll go with the PCl3 first. That is nothing but a phosphorus trihalide which is allowed to do with the hydrolysis with the water. It forms what? H3PO3 and HCl. More about this H3PO3 you are going to understand in the oxoacids of phosphorus. Okay, and it can also react with organic compound which containing the OH group such as CH3COH and C2OH. So here I have CH2COH and PCl3 which gives to the CH2CO, Cl and H3PO3. Again, more about this you are going to learn in the oxoacids of phosphorus, and C2H5OH and PCl5 which gives to the C2H5Cl and H3PO3. So it has a pyramidal shape and which phosphorus which undergo sp3 hybridization. Next we have phosphorus pentachloride. After understanding the phosphorus trichloride, we'll see what is phosphorus pentachloride, how we can easily prepare. It can be prepared by the reaction of white phosphorus with excess of chlorine gas. Okay, so we will take the white phosphorus which is allowed to react with excess of chlorine gas. You will give rise to the phosphorus pentachloride. This is the first way. And we can also prepare this phosphorus pentachloride by the actions of SO2Cl2. Okay, that is sulfur dioxide with chlorine gas, phosphorus which give rise to the phosphorus pentachloride with the formation of sulfur dioxide. So this indicates that even though if you are taking the white phosphorus with the sulfur dioxide in a chlorine gas, which will be leads to the formation of phosphorus pentachloride. And coming into their properties of this phosphorus pentachloride, already I told you that this is a white yellowish or yellowish white solid which is give rise to the pungent odor which gives a strong sensation of smell. With water or with the moisture, it undergo hydrolysis and give rise to the phosphorus oxychloride which is upon further hydrolysis which give rise to the phosphoric acid. So I will take the phosphorus pentachloride which is upon hydrolysis with the water, it forms what? Phosphorus oxychloride with the formation of HCl. This phosphorus oxychloride which is upon further hydrolysis which give rise to the phosphoric acid, that is H3PO4 with the formation of HCl. If you do with the heating, that is with the PCl5, if you heat it, which undergo sublimations and it will be undergo decomposition and give rise to the PCl3, that is phosphorus trihalide with the chlorine gas will be liberated out. Okay, it can also react with some of the organic compounds which containing the OH group such as acetic acid and ethyl alcohol. In ethyl alcohol, this PCl5 which is react and forms a ethyl chloride with the formation of phosphorus oxychloride and also with HCl formation. Similarly, the acetic acid react with PCl5 which gives rise to the acyl chloride and also with the formation of phosphorus oxychloride and HCl will be found. This indicates that this phosphorus pentachloride can also react with the organic compounds which contain the OH as their functional group. Okay. Coming into their next reactions, finely divided metals upon heating with PCl5 which give rise to the respective chloride. Here I have taken the silver which is allowed to react with PCl5 which give rise to the silver chloride and also with the formation of PCl3. Similarly, the lead, that is Sn, which is allowed to react with PCl5 and forms a SnCl4 and also formation of PCl3. You can see that this PCl5 which is undergo decomposition and to give rise to the phosphorus trichloride. Coming into their structure, you can see that it has trigonal bipyramidal structure and it is a gaseous and a liquid phase and it has a trigonal bipyramidal structure, while two axial bonds are longer. You can see that two axial bonds are longer than the equatorial structure as it is shown here below, and three equatorial PCl bonds will be there. You can see that these are the three equatorial bonds which is found with the central metal atom known as phosphorus, and due to this fact that the axial bond pairs suffer more repulsion as compared with the equatorial pairs. So I write with once again, this is a central metal atom phosphorus surrounded by 5 chlorine atoms. Okay. 5 chlorine atom. So these are the axial phosphorus axial bonds and these are equatorial bonds. Due to the formation of the 3 equatorial bonds, this axial bond which experiences more repulsion as it is compared with the equatorial bonds. Okay, and this is a structure of trigonal bipyramidal structure. Okay, this is PCl5, that is phosphorus pentachloride. Coming into their oxoacids of phosphorus, the phosphorus forms a number of oxoacids and it is one of the important one I have mentioned here. So the name I have given, formula, oxidation state of the phosphorus and their preparation. Okay, first one is hypophosphoric acid. Already I have told you that the formula is S3PO2, where the phosphorus will exist in +1 oxidation state and it is obtained by just heating the white phosphorus with strong alkali. Okay, which gives us what? S3PO2. Okay, then orthophosphorus acid, which is also known as phosphonic acid or phosphorus acid. The formula is S3PO3. In that, phosphorus will have a +3 oxidation state and it is obtained by P2O3 which is dissolved in water. Coming into the pyrophosphorus, the formula is P4O2O5 where phosphorus will be exhibits in +3 oxidation state and it is obtained just by taking the phosphorus trichloride which is allowed to react with phosphorus acid or orthophosphoric acid. Okay, and coming into the hypophosphoric, the formula is H4P2O6. In that, phosphorus will exhibit in +4 oxidation state and it is obtained by red phosphorus with alkali. Coming into their orthophosphoric acid, which the formula is S3PO4. Again in this, the phosphorus will exhibit in +5 oxidation state and it is obtained by P2O5 with water and it is allowed to boil to give a orthophosphoric acid. Coming into their pyrophosphoric acids, and the formula is H3P2O7. In that, phosphorus will exhibit in +5 oxidation state. Just by heating the phosphoric acid, you will get a pyrophosphoric acid. Next is metaphosphoric acids or metaphosphoric. In this, the formula is represented as HPO3 n times, where phosphorus will be having +5 oxidation state and phosphoric acid will be allowed to react with bromine water and it is heated in a sealed tube to get a metaphosphoric acids. Coming into their oxoacids of phosphorus. So already I have told that there are many oxoacids of phosphorus will be there. In that only the important one I have mentioned along with the structure. Okay. So hypophosphoric acid and the formula is H3PO2. Why I am writing all these things? For the examination, for the 2 marks or for the 1 mark, they can ask you to write the structure of this hypophosphorus acids or with the orthophosphoric acid or with the orthophosphoric acids. Okay. So the oxidation state of the phosphorus in the hypophosphorus is +1 and basically it is monobasic acid, and generally it is a strong reducing agent and it reduces the silver nitrate to silver. So you can see this reaction, silver nitrate, which is allowed to react with water with the hypophosphoric acid. It reduces the silver nitrate into silver where HNO3 will be formed along with the formation of H3PO4, which is nothing but a orthophosphoric acids. Okay. Next, coming into the orthophosphorus acid, the formula is H3PO3. Oxidation state of phosphorus in this is +3 and basically it is diabasic acid or dibasic acid we call it as. It is also strong reducing agent. It reduces the salts of copper, silver and gold and gives a respective metal. Coming into the last one, that is orthophosphoric acid. The formula is H3PO4. The oxidation state of phosphorus is +5 and it is known as tribasic acids. Okay. Coming into their structure, you can see that this is the first one, that is orthophosphoric acid, where you can see that there are 3 hydrogen atom will be there and we have 1 phosphorus atom and which is surrounded by 4 oxygen atom. And I have pyrophosphoric acid structure where 2 phosphorus atoms are get linked together by oxygen atom and give rise to the pyrophosphoric acid. Coming into their orthophosphoric acid, we have 3 hydrogen with 1 phosphorus and 3 oxygen atom. Coming into their hypophosphorus acid, again we have 1 phosphorus atom at the center, 3 hydrogen atom and 2 oxygen atom. You can see that between the oxygen and phosphorus, we always have a double bond. Coming into that cyclotrimetaphosphoric acid, in that you can see that this phosphoric acid will be looks like a cyclic and meta structure and it is a closed one where 3 phosphorus atoms are get connected like a benzene ring and form in this cyclic structure. And coming into the polymetaphosphoric acid, in this here, this polymetaphosphoric acid will be looks like a chain where each phosphorus atoms are get linked together by a oxygen atom. So this is how we can easily understand how this oxoacids of phosphorus which also looks. In the examination, definitely any one of the questions can be asked to write about the structure of this oxoacids of phosphorus. In the next session, more about only the group 16 elements we are going to understand. So by this, I like to say that, so in this session I have covered only the phosphorus which is belonging to the group 15. Have a look on it. Wherever you are not understanding, please pause the video and please write and practice it. Okay. We'll meet you with the next session. Till that, take care and be safe. Thank you.